Chapter 20, the title reads Inequalities, and so far in intro algebra, we've spent most of our time dealing with the equal sign, okay, equations. Well, chapter 20 is the first of two chapters involving inequalities. Uh, we have 20 inequalities. In chapter 21, we are going to solve inequalities. But the good news is we approach solving inequalities in 21 the same way we do with solving equations. Okay, the rules are the same. We do the reverse order of operations. So before we get to 21, it's important that you understand what these different symbols mean. And here we have 6 symbols. And they simply express that two things are not equal, or they could be equal in some cases, one or the other. So these 6 symbols are approximately. We've probably seen this one before in the geometry chapter. We wrote pi is equal to well, no, I'm sorry, we wrote pi is approximately equal to 22, or if I could write the number that I'm thinking of, we would have 22 divided by 7, or as a decimal 3.14. So we've seen this one before, and you would read it as is approximately equal to. The next one is the less than sign, and we are reading it from the left to right. So when read from left to right, is equal, or I'm sorry, is less than. And then here we have another version of the less than symbol with an equal to bar below it. Okay, just one bar. So we can use this in an instant where one number on the left is less than the number on the right, or we could use it in the case where the left and right are the same number. Okay. Is not equal to, basically an equal to symbol with a slash through it. Is greater than, we've simply reversed the less than sign, so the angle opens up towards the left. And then we have the other version of greater than, is greater than, or equal to. And so with this one, we can have the same number on both sides, and it would still be an appropriate symbol. Okay, one thing you need to know about inequalities is that they can be written in the opposite order. But, for instance, you can write the left on the right side, and you can write the right number on the left side. You can switch the order of the two numbers. But when you do that, you must flip the inequality statement to where it opens up toward the opposite direction that you started. So originally this opened up toward the right, and now it is opening up toward the left. So if you switch the sides, you must flip the inequality. Okay, so what can we conclude about reversing the order of an inequality? That the inequality symbol must also be reversed. Okay. When comparing positive numbers, most people can pretty much pick out the larger number, but it gets tricky whenever you're trying to compare two negative numbers. So, in that case, what you can do if you get yourself confused is you can use a number line, but you must remember that when we construct a number line, we want to increase the numbers as we go from left to right. So from left to the right, we have to increase. Okay, and if you want positive and negative numbers on your number line, a simple way to do this is to just mark 0 in the middle and start, okay, and this is our 0 line. Mark the 0 in the center and count 1, 2, 3, 4, 5 as usual off to the right, and then count to the left starting with 1 again, 1, 2, 3, 4, 5, and then go back and place negatives in front of the numbers to the left. So starting with 0, and that's not 1, this is just our center line. Starting with 0, we go left and right. In terms of the numbers, we start with 1, 2, 3, 4, and count outward. And the numbers on the left have negatives placed in front of them. Okay, so in other words, negative numbers are always to the left of positive numbers on the number line. And so you could say left is always less. If you have two numbers on the number line, the one to the left is always the smaller number. So in example 1, ordering integers, we want to use the appropriate inequality or equal sign. Okay, so which number is bigger, 0 or 4? Well, 4 is bigger. So if you look at the two inequality symbols and you think of it as an alligator's mouth, then what you should assume naturally is that an alligator wants to eat the bigger meal. Okay, you can never satisfy an alligator, so it's going to eat the bigger number, and so the alligator's mouth opens up to eat the 4, the bigger number. So we would use when read from left to right, 0 is less than 4. So if we wrote this out in words, we would say 0 is less than 4. The next one, B, we are comparing 0 and negative 2. And if we mark these two numbers on the number line, here we have negative 2 and here we have 0. Well, the negative 2 on the number line is farther to the left. So negative 2 is less than 0, or to say it another way, 0 is bigger than negative 2. So again, the inequality opens up toward the larger number. Alligator wants to eat the bigger meal. So writing this in words from left to right, we could write 0 is greater than negative 2. Okay, C, this is the initially confusing situation where we compare two negative numbers. Clear my number line, and I go up here and we mark negative 2 and negative 3 on the number line. Okay, here's their positions. Which one is further to the left? Or if we started way on the left and we went to the right, which one do we run into first? The negative 3. And so the negative 2 is bigger. We would use the greater than symbol between the two numbers. Negative 2 is greater than negative 3. And finally, another easy situation, we compare a negative number to a positive number, and automatically the positive number um, is the bigger one, and so the inequality opens up towards the 4. And in words, we can write negative 3 is less than four. The alligator wants to eat the bigger meal, so his mouth opens up towards the 4. Example 2, we want to translate some phrases using inequalities. And so for A, we have 1 is greater than or equal to x. And so we have a 1 and an x, and is greater than or equal to means that we have an inequality with a bar below it, and greater than opens up towards the first number mentioned. So 1 is greater. So the inequality opens up towards the 1, or it can be equal to, so we simply just place a bar underneath the inequality symbol. Okay, A, and then we want to replace this entire phrase with an inequality symbol. A and then 9, and so what do we put in between these two? Okay, we don't know the numbers, so just looking at A and 9, we don't know which one's bigger. So we have to read the phrase is less than. Okay, if A is less than 9, that means that 9 is the larger number, and so the inequality opens up towards the 9, and then we have this equal to part, and so we place one bar underneath the inequality symbol. Example 3, translating a sentence into a one-step inequality. 2 subtracted from y. Okay, a previous chapter we spent a lot of time dealing with phrases that involve mathematical operations and translating them to mathematical symbols. So 2 would just simply give us the number 2 subtracted from y. Okay, the order of subtraction matters, and if we subtract 2 from some other number, then that number goes first, and so the 2 would go behind the y. We'd subtract the 2. Okay, and so we've taken care of this part of the sentence, and now we have the inequality statement is less than. And so is less than points to the left or opens up towards the right, however you want to look at it, and then we simply write the number that follows to the right. So 2 subtracted from y is less than negative 21, y minus 2 less than negative 21. And we're not going to worry about solving these until the next chapter, chapter 21. Example 4 says 10 times the sum of a number and 18. Okay, so in other words, we have 10, and then we multiply it times a sum. Okay. Well, what's the sum? Well, the sum is the number and 18. Sum implies that we add these two numbers that follow. Is at most, okay, this is a sort of a different phrase than what we were given in our table. And so if you say something is at most a particular number, then that basically sets an upper limit on it. And so we have negative 17, and we want to know what inequality we put in between 10 times the sum and negative 17. Well, if it's at most negative 17, then this quantity to the left must be less than negative 17. Okay, and at the same time, it is at most negative 17. It is, in other words, can be negative 17, so we put the equal to bar below it. Alright, but we're not finished. We still want to write a mathematical expression for the sum, and so we go back and we replace the sum with a number n. We were told to use the variable n for the number, and 18 means that we add the two, so n plus 18. So this is at most negative 17. It can be smaller than negative 17, and it can be equal to negative 17. So at most, you could, if you wanted to, add this phrase to your table on the first page. Is at most so is at most, the phrase is less than or equal to. Example 5 reads, we have an A, B, and a C part. We want to write a one-step inequality for a real-world situation. And so A reads, the cargo of a truck weighs no more than 3,000 pounds. Use C for the weight of the cargo. Alright, so C takes the place of this entire phrase, the cargo of the truck. Okay, the weight of the cargo. And so that goes here, C. And then we have no more than. That means that the weight is less than or equal to 3,000 pounds. And so less than or equal to symbol is followed by 3,000. If it was 4,000, it would be greater than 3,000. And we don't want it, we want it no more than 3,000. So C must be less than or equal to 3,000. And we use the equal to because 3,000 would satisfy this inequality. 3,000 itself is equal to 3,000. So we can't say that it's more. A number can't be more than itself. So that's all it told us. It just said that we didn't want the cargo to be more than 3,000. It didn't say that it could not be equal to 3,000. So we put the equal to sign there. B, to qualify for the state championship, a runner must complete the race in at most 45 minutes. Use T for the time. Okay, so in other words, T is at most. Okay, it has to be less than or equal to 45 minutes. C, Yolanda exercises more than 30 minutes a day. Use T for the time. So what's more than 30 minutes a day? Well, 40 minutes is more than 30 minutes. Okay, but we don't know how long she actually exercised, so sometimes just putting real numbers in helps. And we said she exercised 40, and compared to 30 we used the greater than symbol, and so in the place of 40 we put T. Okay, and keep in mind that you could see these reversed. We could write 45 is greater than or equal to T for part B. Likewise, we could write 30 on the left for C, reverse the inequality, and so 30 is less than T. And then for A also, we could have written 3,000 is greater than or equal to C. So keep in mind that the order of the inequality can be reversed as long as you also reverse the inequality symbol. Okay, when we first started talking about numbers, fractions, whole numbers, negative numbers, integers, we talked about how to plot them on a number line. Okay, well, with an inequality, several numbers can satisfy one particular inequality. So we're no longer just simply plotting points on a number line. And as the table here suggests, what we're going to do is we're going to locate a particular number A that's reference to the inequality, and then we're going to shade a line. We're going to shade an area, and you can draw a bold line, or you can scribble out the area that satisfies the inequality like this, and then just put an arrow on the end of it. Either way, but there's going to be several numbers on the number line, and so just not only plotting points but also shading. Okay, so here we have two equivalent inequalities, a greater than x or x less than a. Both of these would be plotted the same way. We locate a on the number line. X cannot be equal to a, and so we don't put a solid dot, we put an open dot, and then we want all the numbers that are less than a, and so we shade to the left. Left is less. Okay, left on a number line is less. The next one, what about x is less than or equal to a? We locate a. We still want numbers x that are less than a, and so we shade to the left again. And we put an arrow just to show that this shading would continue all the way out to negative infinity. But now we have the equal to bar below the inequality. It's less than or equal to. And so at the location of A, we actually shade the dot, a solid dot at the location of the number that the inequality is referenced to. So what you need to get from this is that if it's less than, if x is less than, shade to the left. If we do not have the equal to bar, then we use an open dot. If we have the bar below it, we use a solid dot. If x, as in the case of these last two, if x is greater than a certain number, then we shade to the right. And again, the same rule follows for the dots. Okay, solid for equal to, open for no equal to bar. Alright, so we're going to graph some ourselves. We have m is greater than 2, and so we locate 2. There it is on the number line. There is no equal to bar, so I put an open dot. And then we want numbers that are greater than 2, and those are over here to the right, and so I would shade or scribble out the numbers to the right, and then bold the arrow to point towards the right. Okay, B, we have -3, so we can locate -3, and then what we want to do is decide what kind of dot do we want to put at -3. Well, we actually have the equal to bar below the inequality, and so it can be equal to -3. In other words, -3 itself satisfies this inequality. So we shade it with a solid dot, and then we want numbers x. We want to shade the x values that are less than -3. Left is less, so we start at -3 and we shade to the left. Example 7, write an inequality for the graph shown below. Use x for your variable. Okay, so now we're just doing the same problem except in reverse. We're going backwards. We start with the number line and we want to work our way to the inequality. So let's write x first, and then what we'll do is we'll check what kind of which number are we comparing x to. Well, we're comparing it to a -2, so I'll write that off to the side. And now we want to place the correct inequality in between. Do we have an equal to bar or not? Well, at -2 there's an open dot, so we would not place a bar below the inequality. And we shaded to the left, and that means that the numbers x, this arrow here, this shaded region to the left, represents the x's, and these x's are less than -2. The x's are to the left of -2, so less than. And again, this is an open dot, and so there should not be a bar below this inequality symbol. X cannot equal -2. Okay, let's see. Sometimes we want to graph two inequalities on one number line. And when that happens, it's important to notice the words between the two. This is what represents or indicates a compound inequality. We can have an inequality and another inequality. Okay, inequality and a second inequality. And then on the other hand, we can have an inequality or a separate one. These words are important to pick out. Okay, so when we see these types of inequalities, several ones combined together, how do we interpret the conjunction, if you would, the and the or? Okay, each has a different meaning. If we have the word and between them, then we only want to shade the numbers that satisfy both inequalities. And so when you think and, you could think of the word both. And then if the two inequalities are joined with the word or, then you want to shade both of them basically. So, but we don't want to use the same key word there. So with or, you should probably remember that the number has to at least satisfy one inequality or the other one. Okay. So I don't know, maybe one or the other. All right. And for and, it has to satisfy both inequalities, not just one of them. So in example 8, we're given a compound inequality. So what we can do is we can sort of plot each one on the number line. So the first one I'll plot with respect to a -1. Just looking at this inequality, the first one, we have an equal to bar, so I put a solid dot at -1. And then we want x greater than. Okay, the x numbers that we shade, the inequality opens up towards them. And so this one would shade to the right. So what I'll do is I'll start from the top of my dot and I'll draw an arrow that points to the right instead of shading. Okay, because I'm going to want to compare this first inequality with the second one, which I'll do in a different color. So on the same number line, I'll locate 4. We have an open dot for this inequality because there is no equal sign bar below the inequality, and x is less than 4, so I want to shade to the left. So any of these numbers that this black line covers satisfy the first one. Any of the numbers on the number line that are traced over with the orange line satisfy the second one. But when we have the conjunction in the compound inequality and, we want the numbers that stay shaded to satisfy both of these inequalities. Okay, so another keyword that you can use to remember what you need to do on the number line is overlap. Wherever these two inequalities overlap, we keep that region and we erase the rest of it. And so what I would do is I would clear this part of the number line that only has one shaded region, and then this over here, the numbers above 4, they only satisfy the first inequality, but the numbers in the middle, okay, satisfy both. Okay, and so if we wanted to remove the two lines, we could go back and erase them. We keep the open dot for the 4, okay, because with this open dot, that means that 4 does not satisfy the second one, and we want the numbers that are shaded to satisfy both of them. So 4 gets left out. We shade everything in the middle, And then negative 1 satisfies both because negative 1 is equal to, greater than or equal to itself. And then for the second one, negative 1 is less than the positive number. It is less than 4. 4 is positive, negative 1 is negative, so negative 1 satisfies the second inequality. It satisfies both of them, and so we keep the solid dot. Okay, so B, we have an inequality x is less than or equal to negative 1. So I locate negative 1. I put a solid dot because there's an equal to bar. And the inequality opens up towards the negative 1. And so if I read this from left to right, it would read is less than or equal to, and this or has nothing to do with the compound inequality. This is just what this symbol means, is less than or equal to negative 1. So if x is less, then we shade to the left. Then we have the second inequality, x is greater than 4. X is greater than, there's no equal to bar in this inequality symbol, so just simply x is greater than 4. We locate 4 and we put an open dot, and then we want numbers that are greater than 4, or in other words, numbers that are to the right of 4 on the number line. Now you can see that these two intervals, the blue and the red, share no common numbers. They don't share any numbers. These are negative 1 and below. These are skip 4, anything larger, anything to the right. Now, or means that if the number satisfies at least one of the intervals, then we keep it shaded. So in this case, they do not have to overlap. Okay, we just basically put each inequality on the number line and keep everything that becomes shaded. So this would be our final solution. Whereas in the previous problem, we actually had to erase some of the shading that we made when we placed each one on the number line. Okay, so that was our chapter on inequalities. We'll work with this some more in the next chapter when we actually try to solve the inequalities ourselves and then take a step further and plot the solution.